Movement analysis involves looking at the way a person moves, identifying the movements that are happening at joints, along with looking at things such as the type of contraction, range, plane, and the muscles involved in producing the movement. In a physiotherapy assessment, this is useful to identify factors that may contribute to a patient's symptoms. For example, when they go through a certain range of movement or a certain group of muscles are working. When looking at a movement, we can focus on any joint or part of the movement. So the first thing to do is to identify what we want to look at. If we have a patient who reports knee pain during a squat, for example, we'll probably want to start by looking at what happens at the knee joint during that movement. During the squat, we can see that the knee bends into a flexed position. So we can say that there is knee flexion occurring during this movement. In order to work out what is contracting, however, we need to consider whether the movement is concentric, eccentric, or isometric. Concentric is where the muscle shortens during a contraction. For example, if I do a biceps curl and lift a weight upwards, I can feel that my biceps muscle is working and see that the biceps muscle is shortening. When I lower the weight, however, I can still feel that my biceps are working, however the muscle is lengthening, so this would be eccentric. In most cases, an eccentric movement will occur when a muscle is lowering a weight down in the same direction as gravity, but not always. What is important is where the load is and whether the muscle working is shortening or lengthening. If I lower a biceps curl down and slow down the effect of gravity, then I'm working eccentrically. However, if I use a cable machine and do a triceps pull down, I am moving in the direction of gravity, but because of where the load is, I am now using my triceps concentrically. The other way that a muscle can work is isometrically. Isometric muscle contractions are ones where a muscle is working but not moving. For example, if I hold a weight halfway between flexion and extension at the midpoint of a biceps curl, this is isometric, as the biceps are working but they're not moving. We can see in the squat example that whilst the knee is flexing, because the load is above the knee, it's primarily the quadriceps which are lengthening to control the knee flexion, and it's therefore an eccentric contraction. Once we have identified the type of muscle contraction, we can then work out the agonists, muscles doing the work, and the antagonists, the muscles that produce the opposite action. This is important so we can identify what is working during the movement and what is not working. If you do the movement yourself, it's often fairly straightforward to identify which is the agonist as you feel that muscle working. If we take the biceps curl example, we know that there is elbow flexion and elbow extension. The concentric phase is elbow flexion, and so the elbow flexors are the agonist. The eccentric phase is elbow extension, and so the agonists are not the elbow extensors, but still the elbow flexors. Going back to the squat, it is eccentric knee flexion, and therefore it is the knee extensors, primarily the quadriceps, producing that movement. When we look at range of movement, we are looking at the muscle rather than the joint. In the most lengthened position of the movement, the muscle is in outer range. So starting the concentric phase of a biceps curl would be outer range. The shortest part of the contraction is called inner range, and the middle part of the movement would be mid-range. This means that if a patient only gets pain during a certain part of the movement, then we might need to look more closely at that specific range. In the squat example, the knee is moving from full extension to full flexion, so we would call this full range. But if the patient only got pain at the bottom of the movement, then this would be an outer range, the point at which the quadriceps are fully lengthened, and so this would mean our assessment and treatment process would look primarily at that part of the movement. Finally, we need to consider the plane of movement. If we imagine the patient between two panes of glass, we can work out what plane the patient is working in. If the planes are in front and behind the patient, this will be the frontal plane. Think frontal as in standing in front of a wall. Generally, movements here would be abduction and adduction. Sagittal would be if the two planes were either side of the patient, so generally we would expect flexion and extension to happen. And finally, transverse, where the planes would be above and below the person, therefore allowing rotational movements to happen. In the squat example, we can see that the movement is happening in the sagittal plane, as the patient is moving through flexion and extension. Whilst movement analysis cannot provide us with all the answers, it's still an important skill to develop to ensure that we understand the basic biomechanical principles of functional movement. By observing the way that somebody moves and identifying what components of the movement are problematic, or what structures may be involved, we can build on our assessment findings and identify what areas we may want to focus on during treatment.